Hello students, how are you? Hope you are doing well. Now the question is, P and Q are two identical charged particles, each of mass 4 into 10 raised to the power minus 26 kg and charge 4.8 into 10 to the power minus 19 coulomb, each moving with the same speed of 2.4 into 10 to the power 5 meter per second as shown in this particular figure. The two particles are equidistant 0.5 meter from the vertical y-axis. At some instant, a magnetic field is switched on so that the two particles undergo head-on collision. Find part 1, the direction of the magnetic field, and part 2, the magnitude of the magnetic field applied in the region. So this is the particular problem. So according to the problem, the situation is this particular charge Q, this particular charge P is going towards this direction, positive x direction at this particular instant, and this particular charge Q is going towards this particular direction, that is towards the negative x direction. And it is given this particular problem that they achieve the head-on collision. There is a head-on collision. So the head-on collision due to the presence of the magnetic field, which is switched on at a particular instant of time. So when a particular magnetic field is switched on, the possibility of the head-on collision is only when this particular charge P moves in this particular manner, in this particular circular manner, and this particular charge Q moves in this particular circular manner. So we can say that this is the possibility here, or as it is clear that both should move in the anti-clockwise direction. So this is the anti-clockwise direction. At this particular point, for example, we call this point as R, they collide. There is a collision at this particular instant. So this is the situation. So in the first part, it is asked that what should be the direction of the magnetic field so that there is a head-on collision. So for the head-on collision possibility, we have to calculate the direction of the magnetic field. We know from the concepts of magnetic field that F is equal to Q V cross B. This is Q V cross B. So if we take the direction as the direction going into this plane perpendicular to the motion of the particle, then according to this particular formula, F equals to QV cross B, we can calculate the direction of these particles. For example, this particular expression here is V cross B. So V cross B, the direction of the Q particle is towards this, and B we have taken as the downward direction. So in this way, this is the direction of V, this is the direction of V, and our hand move in the direction of B, the second vector B, in this manner. So the thumb will provide us the direction of force. So we can say that the direction of force looks like this. And as this particle moves in a circular path, this force tends to move to this particular particle in a circular manner. So this particular force provides the centripetal force required to move this particular particle in a circular path. Similarly, for this particular particle also, P particle also, we can easily see that this is the initial direction of the velocity and we are taking the direction of the magnetic field into the plane of the board. So the direction of this uh, fingers, they denote the direction of V and they curl towards B, that is into the plane of the board. So the thumb direction gives us the direction of the force like this. So this is the centripetal force which try to move this particular particle in a circular path, and the particle they collide at this particular point in a head-on collision manner. So in this way we can say that the direction of the magnetic field, first part of the problem is direction of magnetic field. So the direction of the magnetic field is into this plane of the board and perpendicular to the motion of the particle. So we can say that the first part, the direction of magnetic field is perpendicular to the motion of the particle and into the plane of the board of the board of the paper. So this is the direction of the magnetic field. Now the second part, we have to calculate the value of the magnetic field. Now in this particular problem, we see that the magnetic force is provided by the centripetal force. The magnetic and centripetal force are same. So the centripetal force is equal to the magnetic force. And we know that the centripetal force is given by mv square upon r. So mv square upon r is equal to qvb. qvb. Here we have omitted the sine theta. The reason of omission is because sine 90 is 1. Because the direction of the magnetic field is into the plane and the velocity vector is perpendicular to it. It means that the angle between them is 90 degrees and sine of 90 degree means 1. So we straight away take this value as qvb. Now this 1 power of v cancels and we can say that b is equal to mv upon qr. So this is the value of b. Now according to the given data, the mass is given 4 into 10 to the power minus 26. The velocity is given 2.4 into 10 to the power 5 meter per second. The charge is given 4.8 into 10 to the power minus 19 coulomb. And the radius of this particular circular path can be easily seen from the geometry. You can easily see that this particular value is the radius of the circular path, which is 0.5 meters. So putting all these values, for example, m is 4 into 10 to the power minus 26 into v is 2.4 into 10 to the power 5 upon q is 4.8 into 10 to the power minus 19 into r, which is 0.4. So we get this value, final result, as 0.04 Tesla. So this is the value of the magnetic field here. The final result is 0.04 Tesla. So hope you understand the solution. Thank you.